my dear learners, including age group 6 years to the age group of grandfathers. Age is just a number. In this video, we'll be discussing about lists and tuples. So let's get started. So guys, in this video, we'll be discussing about the non-primitive data types in Python. In one of my previous videos, we had discussed about the primitive data types. If you do not know about them, so do check it out now, right? Because it is very essential for this video, right? So in this video, we'll be discussing about non-primitive data types and lists and tuples. We'll be covering sets and dictionaries in the next video, right? Now guys, these data types, non-primitive data types, are also called Python data structures because they store data in kind of a structured way, right? We'll see how, right? So guys, let us start with the list data type. Now guys, all these data types, I told you that Python data structures, they store data in kind of a sequence, right? So list is one such kind of a sequence, right? Now in the list, a list, how do we create a list? So I'll write x equal to, and when we are creating a list, we'll write square bracket, and inside the square bracket, we'll write the values separated by commas. Suppose I write 1, comma 2, comma 3. So this is a list, guys, and you can see this is a list. Now inside a list, we can store data of any type, right? Inside a list, you can store an integer, a float, a boolean, complex string, anything, and also mixed. By mixed, I mean you can also store an integer with a string, with a boolean, right? With anything, with a integer, float, and also these data types, tuples, sets, dictionaries, and also a list inside a list, right? I can also create a list inside a list. So first see this, right? I can also create a list inside this list. And okay, and I can put different values inside this also. So if I print it now, this is the thing, guys. We can create a list inside a list. Any data type we can store in a kind of a sequence in a list, right? And there's also indexing in lists. I can write X, and the indexing we studied in my string operations video, right? You may remember it. The same way it happens here, right? If you write X square bracket for indexing, right? X square bracket and then 1, I get the string, right? And now if I want to access this list, 12 comma 3 list, so I'll write 3, right? And now if I want to particularly access this 12, I write 3 and then again a square bracket. And now inside this list, what is the index number of 12? It is 0. So you'll write 3 and then in another square bracket 0 and gives me 12, right? And inside this list also, this is an amazing thing, guys. Inside this list also, I can store another list, right? Inside that also, I can store another list. Okay, I'm not going too far, but you can do anything. You can store any kind of data inside a list, guys. Right. So, guys, let us discuss about some list methods. Right. We are having many list methods, but I have chosen three which are very important. So, what does this dot extend do? Okay. So, dot extend extends your string list. Like if I'm giving an example, suppose I'm having a equals to 1 comma 2 comma 3, this is the list and I'm printing a, right? And now I write a dot extend. Now by using this dot extend, I will add new elements to my string, right? I'll write square bracket. You need to write the square bracket, guys, and then you'll give whatever values you want to add. Suppose I write string comma 23.2, right? And now I try to print a, and what I see, it gets extended, right? New elements have been added, right? Guys, a similar method is dot append. What it does, it also adds new elements to your string, sorry, list, but when you're using dot append, only a single element will be added to your list, right? Let us see. Okay, I'm using the same list a dot append, and now if I give, now there's no hard and fast rule of writing in square brackets, right? So if I write 12, so let us see what happens. Okay, and I printed it. Print A. So 12 gets added, but if I try to add multiple things here, so it throws me an error, right? And if you do it in a square bracket as an individual, as a single element, this will be added in the list, and you can see this. In extend, you can add multiple items in the list, and using dot append, only a single item will be added to your list, right? Now, guys, coming over to this dot split method, guys, this is not a list method. Sorry, I said list method. This is a string method, right? So how does this work if I am having a string, say x equal to 1, 2, and 3, right, separated by a space. And now if I write x dot split, now what will split do? It will, okay, sorry, it will split the string by some character and create a list out of it. And what happens is you see here, I gave the space. So by this space, the characters were separated and made a list out of that, right? And what I can also do is if I put a comma there and want to split the string by a comma, so you can see here the output is in front of you, right? So this is a string method, not a list method, right? Now, guys, let us see our tuples, right? So, how to create a tuple? Tuple is just like a list, okay, with some difference. I'll tell you, it's just like a sequence of values, just like a list. Okay, the difference, there are two differences mainly. Let us go on to the first difference. So, if I create a tuple named tup1, okay, so I write, okay, so when you're creating a list, you use square brackets, but when you're creating a tuple, you use these parentheses, right? So if I'm creating a tuple, say tup1, so I'll write suppose 1 comma 2 comma, okay, string. So here also you can use multiple data types, okay, any kind of data type you can use inside these tuples, even a list, set, dictionary, another tuple you want to create inside a tuple, that is also possible, right? The difference is that you're using parentheses here, right? And in lists, we use square brackets, right? And if we say, so this is created here. So guys, talking about the difference in tuples and lists, the concept of mutability and immutability comes, right? So what is mutability and immutability? Guys, we can, like, I categorize data types into primitive and non-primitive. We can also categorize data types into your mutable and immutable data types, right? In mutable, I'm having lists, sets, and dictionaries. And in immutable, all the other data types, integers, strings, none, and tuples also. Boolean, complex, oh, I missed float. Float will also come here. So tuples come in an immutable data type, whereas lists, sets, and dictionaries come into the mutable data types. And let us see it into action, right? So guys, talking about mutability and immutability, let us take a mutable data type list. So if I create a list, say a equals to 1 comma 2. Now in a mutable data type, you can change the values. So suppose I want to change the values of a. Suppose at the 0th index, I am having 1. So suppose I want to write the 2 only. I want to replace this 1 by 2. So I'll write a 0 and then I can put an equal to and I can just write 2, right? Simple. And if I run it and print, okay, print a, and now if you see it has come 2 comma 2. Okay, and you can also extend the string. That is, you are able to modify your string, right? But this is not the case with tuples, guys. I am having this tuple tup1, okay, and if I try to change the value of suppose the 0th index only, okay, and I want to write the 2, and if you check this, you are getting a type error. Tuple object does not support item assignment. This is the thing, guys. This is mutability and immutability. Other immutable data types also, same thing you can see, right? If I talk about a string, if I talk about a string, say x equal to str, and if I try to change the 0th index, this will throw a type error. Str string does not support item assignment, right? But guys, you may see that we have learned about variable reassignment, that we can assign a variable with a new value. Suppose I was having a integer and I was able to assign some new value to the same integer, same variable, right? But what actually happens, guys, in the memory of Python? Let us see what happens. Okay, so if I am printing the value of this id x, right? And just let me cut it. Okay, this is the memory location of this variable x, and now I'm creating variable x again. Okay, x equal to 23 now, and now I'll try to print id x. Let us check it. So you see it, guys. They are in two different memory locations. That is, this x is not this x. They are being stored in two different storage blocks, right? So it is not that the value of x is getting modified. That is why integer is an immutable data type, right? But if you do the same thing in a list, okay, we had done it here, right? And if I here print id a, and if I do it now here id a, then you see they are the same memory locations, right? Now, guys, in tuples, we are having basically two methods only. One is dot count, right? Dot count, and the other one is dot index, right? Very easy method. Okay, dot count, what it does, suppose, okay, I'm having a tuple, say b equal to 1 comma 2 comma 3 comma 4 comma 2 comma 1 comma 2, right? And now I want to count the number of twos in this tuple, right? So I'll write b dot count, and inside the count I'll write 2, and I get 3, 1 2 3, right? And how does the dot index works? It will check at right, in the index you'll write, okay, suppose I want to check the index of 3, where 3 occurs, right? So I write dot index and 3. So it tells me at the second index now, right? So it's at the second index, and if I check it for 2, now I'm having multiple 2's, but it will give me the index at which 2 occurs for the first time, right? So it's the first index, so it gives me 1, right? And you can also do slicing with tuples and lists in the same way that we did for strings, right? So guys, I want you to do it yourself. Explore concatenation, slicing, okay, indexing, all these operations with lists and tuples, right?
पूरा इंडिया पढ़ेगा डेटा साइंस. Ready for my next video? So goodbye and namaskar. Please like, share, comment and subscribe to my YouTube channel. Don't forget to press the bell icon.